What if I told you that in the next 10 minutes you'll program an Arduino to control LEDs, read sensors, and run motors without writing a single line of code? Today, we are exploring Mind Plus, a visual programming platform that changes the way we learn Arduino. Stick around because by the end of this video, you'll have everything you need to start building your own projects without a single line of code. Let's be honest, you want to build cool projects. But if understanding variables, functions, and libraries overwhelm you, this tool can help you. MindPlus is a visual programming environment that lets you program Arduinos using drag and drop blocks instead of text code. Think of it like digital Lego blocks for programming. Each block represents a command or a function, and you can snap them together to create your program logic. But here's the genius part. MindPlus automatically generates professional Arduino code behind the scenes. You get all the power of traditional programming too. To get started, head over to mindplus.cc and download the free software for Windows, Mac, or Linux. Once downloaded, install it. When you first open MindPlus, there's a chance that the default language is Chinese. To change that, click on the settings button here and choose your preferred language. Then on the left, we have our block categories, everything from basic logic to advanced controls. The center area is our programming canvas where we put the blocks in and build our project. And on the right, we can see the generated code and monitor our Arduino's output. First off, as you can see, there are no Arduino code blocks here. To fix that, go into the extensions by clicking the button here and select Arduino Uno. That's it. Then click back and voila, we have our Arduino block section. And the block area is updated with the basic loop block. So basically these are two blocks. This indicates the boot up of the board, and after that this is our loop function where in which the code is run forever in a loop as fast as the board can process it. The built-in LED on the Uno is connected to pin 13. So let's find the digital pin block, pop it in there and change it to pin 13 and set it to high. So this will set the digital pin 13 to high, so the LED will light up. And again we want to turn it off, so again select pin 13 and set it to low. But since the Uno can process this code faster than you can see, it will probably turn it on and off at a speed that you cannot see. So what we want to do is leave a little gap in between these two. Go to control section and there we have the wait 1 seconds block. Drag that and add 1 for each output. These can also be changed to be different seconds, but we'll just leave it at 1 for now. And as you can see, the Arduino code is updated automatically where we have a digital write to high and digital write to low and the delay in between. Oh, I forgot to connect the device. After you have connected it to the computer, you need to select it in connect device. There is our Uno and hit upload. There you go. You can see the LED. And that's our first program. Let's change this to 0.5 seconds. Upload it again. Now it is blinking faster. And that's it. That's the blink program. So like this, you can access all the basic functions of the Arduino Uno, like reading digital pins, reading analog pins, and setting the digital pins. And there's some built-in blocks for sensors like ultrasonic or playing tones. or infrared receivers. Next, let's try doing the blink sketch on an LED outside the board. I mean, an LED that is not the built-in LED. So let's grab an LED and connect it to our Uno. Always connect a resistor when using an LED on a microcontroller. Disconnect the power always, and let's grab some jumper wires. Ground, connect the ground, and let's say pin 8. So the output from pin 8 goes to the positive terminal and the ground goes to the ground. Now connect the power. Now change this to pin 8 and upload the code. And this is not all. You can also control other modules like display modules or motors. Just go into extensions again, make sure the Arduino Uno is selected, and go into sensors. So here you have a list of modules that are supported by this program, and there are also communication devices and displays. So let's start with an OLED display. So select the OLED display. This does say DF robot display, but I'm guessing it should work with any OLED display. Go back. Now we have a new section called display. Okay, let's get rid of the old okay, and so we need to initiate the display address. So if you've never worked with OLED displays or any other I2C devices, you need to initiate them using their address. Most displays have this address. We'll try running the program, and if it doesn't work, we will change it. So once you drag this, note that this does not go into the forever block, because this needs to be run only once. So we just leave it outside, which generates the code inside the setup function. Okay, and then we want to display text talkies on line 1. So we only want to initiate the display and display this text once, so we don't need to put anything in the forever loop, because I want to check if the display works in the first place. Let's go ahead and wire a display to our Uno. And here I have an OLED display. So I connect the ground and VCC to the 5V and ground of the Arduino pins. And the Uno has the SCL and SDA, the I2C pins broken out separately on that side of the board. I am going to use those pins because it's easier. So the SDA goes to the SDA and the SCL goes to the SCL. And I'm going to upload the code now. If it works, it should turn on the display and show the text. There you go. Now let's add another line. So this block was displaying tech talkies on line 1, and we can add something on line 2. Hello world. Upload. Perfect. So this should display hello for 1 second and world for 1 second. I'm not sure if we need to add the clear display, but we will upload and find out. That's how we learn. Oh, perfect. We didn't need to clear the screen. Alright, that's it for the display. Yeah, sounds fun. Let's add the micro servo, the actuator section. Okay, it has only one function, which is all we need to control a servo motor. Okay, and plug the motor onto pin 2. So that's what we will change. So this sets the servo to 90 degrees. So what we can do here is we can set the, oh, that's neat. We can set the angle manually like this, or we can add a variable. A variable is nothing but a value, a name for a value. So make a numeric variable, servo angle. Alright, and it shows up here. Before we can start using the servo angle, the variable, we need to set it first. So at the beginning of the program, we set servo angle to 0, and we set the servo motor, which is on pin 2, to the value of servo angle. So going forward, we will not be typing the angles manually, but rather setting the servo angle variable and using that. So the servo motor will be set to the servo angle degree, which is at the beginning 0. So at the beginning of the program, the motor is going to go to 0 degrees and then enter the loop. Every time the loop is processed, we want the angle of the servo to increase. For that, we use the change by. So there are two blocks we can use to change a variable, which one is set and one is change. So using the set variable, we can set it to a specific value, say from 0 to 90. But using the change variable, we can change it by a certain amount. So if I say change servo angle by 10, from 0 it goes to 10, and the next time from 10 it goes to 20. So when it enters the loop, it is changed by 10 and it sets the servo to the servo angle variable. So technically this should increase the servo's angle by 10 degrees very fast though, because we have not included a wait. So we can wait half a second and change the angle. But the problem is the angle is limited. It cannot go over 360 degrees. So at 360 degrees, the servo angle value should go back to being 0. But let's run this code and see what happens. There you go, it starts increasing at 10-degree angles. That's it. It doesn't go over a certain amount of angles. So if you have a 360-degree motor, it might go to 360, but mine is a 180-degree motor. So as you can see, it started at 0, hit 180 degrees and just stopped, because after that it doesn't know what to do with the values. So let's cap the values at 180. If it is above 180, we need it to go back to 0, for which we will use the if block, which is a block that says if a condition is true, then do what is inside the loop. So we put this above the set servo block, and we come to the operators. So we need to check if the value is above a certain amount. So for that we use the greater than operator, and then we need our variable. If the servo angle is greater than 180, then set the variable. So set servo angle to 0. So every time the angle goes above 180, it sets it to 0 before passing it to the motor. This should work. Let's upload and check. There you go. We're at 90 degrees, approaching 180. There you go. Once it hits 180, it goes back to 0. Next, I want to try another display which I find interesting, very interesting. The dot matrix display. Let's add that, and it has two functions. One is to initiate the display, the other one is to show a pattern. The reason I really like using the display with this app is it has a graphical interface where you can draw the pattern you want to make on the board, which is pretty cool. Okay, here's the display. It is controlled by 3 pins: the clock, the CS and the data pins, and 2 more pins for the power, a total of 5 pins. And so in the code, the data pin is 2 and the CS pin is 3 and the clock pin is 4. And in the code we already have set it up to show a symbol. So let's just connect it and upload the code to see if it is ready to work. There you go. I don't know if you can see it, but yeah, that works. Next, let's see how we can get basic sensor readings onto the serial monitor. Okay, let's pick a sensor. Oh yeah, the famous DHT11 temperature sensor. Okay, and yep, there's a simple read. Oh, okay, that is not a code block, that is a value block. You can see that from the shape. It's roundish, so it's a variable. All the variables are round, all the control blocks are like this, and the operators which give values out are also round. We'll basically have to pass this value, the sensor value, onto the serial monitor, so that we go to the serial port operations. And what do we need? Serial output, right? So serial output. So as you can see, usually when you code, if you want serial output, you do serial.print. But if you forget to add serial.begin, this does not work. So as you can see, once you pop this in, that is automatically added for you. And instead of hello, we give this variable and we connect to 5, and the variant I am connecting a DHT11 sensor, and we want to get the temperature. Okay, and no wrap, because copy this and paste. I also want to display the moisture, and then wrap, and then we wait for 1 second before we read it again and display it on the next line. So this code should work. Let me just grab my DHT11 sensor. So there's my DHT11 sensor. As you can see, it has seen better days, but it still works. So we connect power, and we just need one pin, and in the code we have defined that as pin 5. Where is pin 5? 5. That's it. And upload the code. We need to turn the serial monitor on. Okay, the problem here is we have not given any gap, or I mean practically nothing between the temperature and the humidity reading. So let's grab another serial output, put them in between, set it to no wrap, and make a space, a comma, and a space. That's it. Upload it again. Open the serial. There you go. So 26 is our temperature and 71 is our humidity. Okay, let's see if it is actually working. So there's a long list of sensors that works with the app. There's plenty, like a joystick module, an infrared motion sensor, and you can control the MP3 module, even relay modules, stepper motors, GPS, even a PS2 controller. That's pretty neat. They even have built-in functions like an I2C scan. This is very useful if you have multiple devices and you are not able to figure out the addresses of the devices. Let me know in the comments if you want me to post more about this software and explain more about the sensors and the shields and the functions. I'll see you in the next video, because the learning never stops.